Welcome back to this FP2 video on first order linear differential equations of the form dy by dx plus py equals q, where p and q are functions of x. Okay, so this is the second video now in our first order differential equations, and we're going to be looking at equations that are of this kind of form. And I think the easiest way to explain this is to jump straight into the first example. So here we have the first example. Find the general solution to the differential equation x to the power 4 dy by dx plus 4x cubed y equals sine x. So for this one, it's about, well, kind of spotting something. So I'm going to show you kind of in advance. So before we actually look at solving it, if I had this, okay, just imagine now this is part of an expression or, something like that, but we're going to differentiate it implicitly. So for this, what I would do, I would call u x to the power 4 and v y. And this would be du by dx, which is 4x cubed, and dv by dx, which is dy by dx. And then differentiating this, so my dy by dx would be equal to u dv by dx plus v du by dx. So this x to the power 4 multiplied by y would differentiate to 4x cubed y. It would be x to the power 4 dy by dx plus 4x cubed y. And what do you notice about this? This is this up here. Okay, x to the power 4 dy by dx and 4x cubed y. So if I differentiate x to the 4y, this is what I get. Okay, so that's what we're gonna kind of start our process and our thinking just into the kind of introduction to this. So my equation, I'll just write it down here. Looks like this. And now I can replace this, which is here, with this. So that's d by dx of x to the power 4y. Now, as integration is the reverse process of differentiation, if I integrate both sides, I get x to the 4y on the left, and then I get the integral of sine x dx on the right. And integrating sine, so sine differentiates the cos but integrates to negative cos. So this is negative cos x plus c. And then I want to make this y equals, so I divide by x to the power 4, and I get minus 1 over x to the power 4 cos x plus c over x to the power 4. Okay, and that c is just, a constant. It could be replaced by another constant, but I will leave it like that. And this type of differential equation can be always solved in this way, and it's about spotting it. So if you see something that is basically when I've got a function of x dy by dx plus the differentiation of that function multiplied by y, then it will equal that function of x times that y differentiated. Okay, so like in this case, the function of x is this x to the power 4, and then so it's x to the power 4 dy by dx, and then looking over here we get this differentiated 4x cubed multiplied by y. And if I spot that in a question, then I can use this to replace it with this. Okay, so this one now is about spotting them. Okay, and if you can spot it, then it's fairly straightforward. Let's have a look at another example. So here we have find the general solution to the equation dy by dx plus 4y over x equals sine x over x to the power 4. Now we can multiply this by x to the power 4, and that will give me x to the power 4 dy by dx plus 4x cubed y equals sine x. And by multiplying by x to the power 4, this will turn this into an exact equation, which is, as it happens, the exact equation in the previous example. So I know that the solution to this equation is y equals minus 1 over x to the power 4 cos x plus c over x to the power 4. And this multiplying by x to the power 4, this is known as the integrating factor, this x to the power 4. And multiplying it turns it into an equation of this form, which is then straightforward to solve. But how do we go about finding what this integrating factor is? You know, in this case it was straightforward, multiply by this x to the power 4, and we had it in this form, and then we could solve. But it's not gonna always be obvious. So let's look at this general form, dy by dx plus py equals q, and if we solve this, it will then give us what the integrating factor is to be able to solve other differential equations. Now in this video I'm not going to go through solving this, it's straightforward. You can find it online or in your textbooks. I'm just going to jump straight to what we're going to be using. So the integrating factor is going to be e to the integral of p dx. So that is what we're going to do. So when we get a differential equation, we'll put it into this form, find the integrating factor, and then multiply by it. Okay, now it will give us something that will be in this form. So e to the integral of p dx y equals the integral of e integral p dx, the integrating factor, times by q dx plus c. Okay, but we won't worry about this bit. This bit is just the form that you'll see will come out every single time. So we'll change into this form if it's not already in this form, find the integrating factor, multiply by it, and then we'll find the general solution to the differential equation. So let's have a look at how that works now. So here we have a question, find the general solution to the differential equation. Here it is, and it is already in the form dy by dx plus py equals q. Okay, so what we need to do is we need to find the integrating factor, and that is going to be e integral of px. That's what we're going to be doing. Okay, so p, if we look at this form, p, and I'll do this in red, is this -5 here. So we're looking at e integral of -5, okay, dx, which is going to be the e to -5x. Okay, so this is now the integrating factor. So I'm going to multiply my original equation by this. So e to the -5x dy by dx minus 5e to the -5x y equals e to the 2x multiplied by e to the -5x. Now, when I look at the left-hand side now, this is basically the function multiplied by y differentiated. So if I write this down first, and then I'll talk you through it. So if I differentiate this, e to the -5xy, I will get this and this, because this times this differentiated, which is here, plus this differentiated, which is that, times this, which is here. Okay, so that's the left-hand side. On the right-hand side, I can simplify to e to the -3x. Okay, so by multiplying by this integrating factor, it then creates the form of the very first example, okay, where I can put these two terms together to be the differential of a single term here. Now I integrate both sides, so e to the -5xy equals the integral of e to the -3x dx. So e to the -5xy is e to the -3x. Now when I'm integrating it, it's going to be multiplied by -1/3 plus c. Because if I differentiate this, it stays the same, but I multiply by -1/3, which will again get me back to there. So that's what I've got, and then what I need to do is just divide by e to the -5x. So dividing by e to the -5x gives me -1/3 e to the 2x plus c over e to the -5x. Okay, and then that can be written as -1/3 e to the 2x plus e to the 5xc. Okay, because it's a negative power, I can take it to the top. So that now is the general solution to this differential equation. And the form I was saying not to worry about in the last one was basically down here. Okay, and you can see it just comes out as you do the maths. Now I think it's worth having a look at another example with this. So here we have this differential equation. Now if I divide through by cos x, I'll have it in the form dy by dx plus py equals q. Okay, so dividing through by cos x, I get dy by dx plus, now it's 2y, and then sin x divided by cos x is tan x equals cos cubed x. okay, because dividing x to the power 4 by a cubed will give me the cos cubed. Now we want to find the integrating factor. So integrating factor. Now that is e to the integral of p dx. I don't know if I said the dx on the previous one. I might have missed it out. I can't remember. But yeah, that's what we're looking at. So p is going to be 2 tan x, isn't it? So we're integrating 2 tan x dx. Now tan x integrates to log to the base e sec x, so that'll be 2 ln sec x, which is e to the ln sec squared x, which is just sec squared x. Okay, so that is my integrating factor. So multiplied by sec squared x. So that's sec squared x times dy by dx plus 2y tan x sec squared x equals cos cubed x sec squared x. Now I can go ahead and just simplify it. Well, actually, before we simplify it, we'll jump to this stage on the left. So it's going to be sec squared x times by y. So I normally write like that for everything else, but because we're looking at a trig identity, it's better to write the y first so it's not confused as being part of the trig identity. And then cos cubed times sec squared. Now sec squared is 1 over cos squared. So cos cubed divided by cos squared is just cos x. Then integrate both sides. And we get this. Now cos differentiates the negative sign, so it integrates the positive sign. So y equals sine x over sec squared x plus c. Or I could write, that would be sec squared x there. Or I could write it as sec squared is cos squared x. And that's sine x plus c, like that. Of course, I could do it without the brackets and have cos squared x times sine x plus c cos squared x. Okay, either way, this is now my general solution to the differential equation. But hopefully you can see with these examples that, you write this in the form of dy by dx plus py equals q. Then find the integrating factor, and then you can use that integrating factor, you multiply by it, and then it's straightforward. Okay, just like that first example. So in general, you're not going to get a question like that first example where it's dead easy. It will be fairly easy, I think, these, but you just find that integrating factor first. Okay, so now we're at the kind of point in the video where I just want to remind you to like the video if you found it useful so far, subscribe if you're yet to subscribe, and click that join button if you're willing and able to help me out financially. It really will help me make more and more videos in the future. Otherwise, let's look at a few questions. So 4 questions here. They're all past paper questions. So have a go. Pause the video now. Okay, hopefully you've had a chance to have a go at these questions. Let's run through the solutions. Okay, so part A, first let's find the integrating factor. So P integral e to the power the integral of P dx. So that's e and the integral of 2x dx, which is e. Now 2x will integrate to 2x squared over 2. The 2's will cancel, so this is e to the power x squared. So that's what I'm going to multiply by. So e to the x squared dy by dx plus 2x e, let me put 2x y e to the x squared equals e to the minus x squared times e to the x squared. Now this on the left, now these will be from differentiating e to the x squared y. And then on the right, if I multiply these two together, I add the powers. So it's going to be e to the power 0 or 1. And then integrating both sides, so we get e to the x squared y equals the integral of 1, which is e to the x squared y equals x plus c. So y equals x over e to the x squared plus c over e to the x squared. Or I could write that as x e to the minus x squared plus c e to the minus x squared. So there's my differential equation. Now for part B, describe the behavior of y as x tends to infinity. So in these cases, obviously x is getting large, but e to the minus x squared, that's going to be heading towards 0. So as x tends to infinity, this will be heading towards 0. So 0 times anything is 0, and 0 times anything is 0. So as x tends to infinity, y will tend to 0. So there you have question 1. Okay, question 2. So first, well, I could divide by x straight away, I suppose, first of all, but I've done it this way now. So what I've done is I've taken this x to the other side, but really I could have divided by the x first. Okay, just getting it in the form of dy by dx plus py equals q. Now let's find the integrating factor. So p is x to the minus 1 or 1 over x, so we're integrating 1 over x dx, which is log x, which is just x. So in this case, it was already in that form. So x dy by dx plus y equals minus x. So if you had spotted this was in the correct form right from the start, you could have skipped this step, but just rearranging and doing this step, you'll always get it right. So this now is the differential of xy, and that makes total sense. X times this differentiated gives me this, and this times this differentiated gives me this. Now integrating both sides gives me, and now I'm integrating minus x dx. So xy, this is going to be minus x squared over 2 plus c. So y is going to be equals to, so dividing by x, we got minus x over 2 plus c over 2. Sorry, I mean c over x. So that's y equals minus x over 2 plus c over x, because we divided by x there. Just saying x over 2 and then I just said over 2 again. Don't know what was going on in my head, but that's a nice straightforward question. Let's have a look at number 3. So it's already in the correct form, so we can find the integrating factor. So p in this case is going to be tan x. So I'm integrating tan x, which is e to the ln sec x, which is going to be sec x. So that means our equation becomes sec x dy by dx plus y tan x sec x equals 2 sec x sec x. So on the left now we get that this is the differential of y sec x. And on the right that's going to be equal to 2 sec squared x. Now integrating both sides we get y sec x equals the integral of 2 sec squared x dx. Now the integral of sec squared x is tan x. So this is going to be 2 tan x plus c. So y equals 2 tan x over sec x plus c over sec x, which I can simplify to. So tan is sine over cos, and sec is obviously 1 over cos, so this becomes 2 sine x over cos x times cos x, which will cancel there, plus c cos x. So this is 2 sine x plus c cos x. And this is question 3 complete. Let's have a look at number 4. So we'll start by finding the integrating factor as it's already in the correct form. So this is going to be e integral of p dx, which is e the integral of 1 over x dx, which is e ln x, which is just x. So this is x dy by dx plus y equals x to the power of half times by x. So this is differentiation of xy equals x to the power 3 over 2. Integrating both sides we get xy equals the integral of x to the power 3 over 2 dx, which is add 1 to that, so 5 over 2, divide by 5 over 2, so we get 2/5 plus c, and then divide by x, so that's 2/5 x to the 3 over 2 plus c over x. And that is question 4. So hopefully you managed to do these questions. Believe it or not, they're generally worth 7 marks, each of these questions that we looked at here. So easy marks in the exam if they come up. Obviously, these aren't the only type that come up. So in the next video, we'll look at reducible first order differential equations. Okay, but until then, don't forget to like this video if you found it useful, subscribe if you're yet to, and join if you're willing and able to help me out financially. Also, feel free to comment down below. I do read a lot of the comments, but I am one person, so I can't always reply to every single comment, but I do try my best to reply to the vast majority. Okay, so don't forget, feel free to leave comments down below as well. Otherwise, I'll see you in the next video.